Hello everyone and welcome to your lesson of physics. In this video, I'll be trying to solve the worksheet of magnetism and electromagnetism. And basically I've chosen the questions that are common between kind of every board CIEs and at Excel course, GCSEs and IGCSEs. Alright, so let's start with it. Question number 1. We have magnetic field lines show the shape and direction of magnetic field. The diagram shows a cross section through a wire placed between two magnetic poles. Okay, you can see that cross section of the wire is shown, like the front face of the wire can be seen, which is placed inside the magnetic field. The wire carries electric current into the page at X. So basically we all understand that if you have a cross sign over here, that means whatever quantity it is given with, that is directed into the page, away from you and into the page. If we represent like cross, if you write cross with the force, that means forces into the page. If you write it with current, that means current is into the page. Right, so this is just the information that we have. The shape of the magnetic field is shown. Okay, then we can see the shape as well. Add arrows to two of the magnetic field lines to show the direction of magnetic field. Okay, this is one of the easiest one. The general rule of thumb is magnetic field lines emerge from North Pole and they are directed towards the South Pole. So you have to choose any two of these magnetic field lines and then you have to draw the arrows in such a way that arrows are from the North Pole towards the South Pole. Okay, you can draw two arrows on any of these two lines. Okay, you can draw it like, don't need to like exactly draw near the conductor, you can draw it anywhere. All right, then we move on to part 2. Draw an arrow on the diagram to show the direction of force on the wire. See, that question is of 2 marks because you have to use a rule in that, and if you don't understand that rule, if you're not able to apply it, won't be getting any marks from here. So it's not a very simple one. Many students find it very complicated. First of all, the rule says, if you remember the rule, it says that your forefinger, okay, it should be in the direction of magnetic field, and index finger, it should be, sorry, index or forefinger is just the same thing. Your middle finger should be in the direction of current, and your thumb will point towards the direction of force. Okay, so basically I'm not explaining the rule in that case. We need a separate video for that. So we are just applying the rule here, provided you understand how do we apply that rule. So if you stretch your 3 fingers in a way that they are perpendicular to each other, you'll find out that the force is directed towards left. Okay, it is directed towards left, but then you have to label that force by F. So you can write F over here. Now again the question is, how do we know the direction of this force? And the answer is we apply the Fleming's left hand rule. Okay, I'll be like making separate videos about the concepts where I'll be explaining these rules as well, but here I assume that you know how to apply the Fleming's left hand rule. Now if some of you struggle with it, they like can see there's a cheat as well which can tell you the direction of force. Okay, so basically you have to keep in your mind, going to like raise out this thing. Okay, so this works whenever you need to find direction of force in this kind of case. Okay, so here's a cheat code. So basically you should know that we will always be referring to 6 sides. One of the two of those sides are left and right. Like for any three-dimensional object, we can have three separate sides for it. Okay, we call one of them left and right, which can be called along x-axis. Then we have one side that you call up down, upward or downward. When I write upward, up down, it means it might be upward, might be downward, but it would be vertical like this. Left and right would be horizontal like this. And the third one would be into the page or out of the page. Into the page or out of the page. You can write it with the dot and cross. Dot represent out of the page, cross represents into the page. All right, so in these kind of questions you'll always be having this these three pair of sides. Now think about it, up and down. Okay, that direction is already occupied by magnetic field. Magnetic field is from top to bottom, from up to downward, upward to downward. That is your direction of magnetic field, from up to down. So this one is already occupied by a magnetic field. All right. Then current. What about the current? Current is already occupying into and out of the page side. Matter of fact, it is occupying into the page. But anyway, this pair of direction, into or out of the page, it is already occupied by current. So you're left with two sides, possible side, left and right. Okay. Now your force cannot be directed upward or downward. It cannot be directed into or out of the page because these sides are already occupied by magnetic field and current respectively. And the force has to be perpendicular to both of these, so it has to be either towards left and towards right. Right? Now you have a 50% chance of getting it right. It has to be either left or it has to be either right. Now, how do we choose from left and right? You see, this region represents more magnetic field lines. It represents stronger magnetic field. And this region, on the other hand, on the left side, presents few number of magnetic field lines. Right? It represents weak magnetic field. So the force would always be directed from strong magnetic field towards weak magnetic field. So the force would be directed from right side towards the left side. So the direction of force would be, the final direction of force would be towards left. So I mean, at the very basic, you're actually applying the left hand rule, Fleming's left hand rule. But if you're not like able to curl your fingers or keep your fingers in that way, and you always like get confused with it, then you can keep this in your mind. But I would suggest, but I would recommend that you should be aware of Fleming's left hand rule, because sometimes the question is straight away you get a question to define Fleming's left hand rule in order to find force. And one more thing, uh, quite often students get confused, like if they need to find the direction of force, which rule they should be using. Should they be using like Fleming's left hand rule or right hand grip rule? No, I just tell them to keep in your mind that in left you get the F, which can say stands for force. So the left one, the left hand rule, is the one which can be used to find the direction of force, because you get F in left, you get F in force. So just you can like keep this trick in your mind. We don't use right hand grip rule, that is used for other purposes. Left hand rule is a rule that is used for finding the direction of force acting on the conductor, which is placed in a magnetic field. All right, and then we have the next one that says, how would you explain how you could use a plotted compass to investigate the magnetic field around a bar magnet? You may draw a diagram to help your answer. All right, once again, this is kind of an easier one. So basically you have to draw a magnetic field around a bar magnet. So in order to like find the direction of magnetic field around a bar magnet, there is a generic answer for that. Generic answer means every time you get a question like that, you can write down the same statement. So you get like 2-3 mark question from here using plotting compass to investigate magnetic field around a bar magnet. So first of all, you can note down these points and would be generic statement. Place a compass near near the edge of North Pole. All right, so here's the part C, the extension of the previous question. Explain how could you use a plotting compass to investigate the magnetic field around a bar magnet. So basically the magnetic field around a bar magnet, the pattern of the magnetic field can be demonstrated or investigated with the use of plotting compass or the method of like iron sprinkles. So in this one, they have asked you about the pattern of magnetic plotting compass. So these are the pointers. First of all, the statement that I'm going to write is a generic one means whenever you get a question like that to explain about the process finding magnetic field pattern around a bar magnet, you can write this answer straight away as it is. So the first pointer is place the plotted compass near the edge of North Pole of your magnet, of a magnet. All right, that is the very first pointer. Secondly, mark the pointer or mark a dot, mark a point in the direction of needle. In the direction of needle. All right. And the next one is now place that compass on that point and mark another point in the direction of needle. Place the compass, plotted compass, on that point and mark another point in the direction of needle. All right. Once again, I'm repeating this is generic answer. So you write this answer straight away for any question like that. So once you do that, repeat the process of marking points until South Pole is reached. Until South Pole is reached. And then the final step, you link the directions together. Okay, link all the points together to get a field line or field pattern. All right, so you go around for one line, you join all the points, you get one magnetic field line, then you can like start moving from the lower side and then you get another field line by joining all the points, and that way you get the magnetic field around a bar magnet. Okay, the diagram is always like recommended to draw the diagram. I mean, it's not difficult at all. This is your magnet, and this one, let's say, is the north pole. This one is the south pole. So you start with placing the compass over here. All right, you place the compass over here, and the needle will point somewhere, and in that direction you draw a dot. Then replace the compass on that point. And matter of fact, you can bring a new plotting compass as well. You can use like multiple plotting compasses at the same time as well. You place it over here, needle will point somewhere, then you draw a dot over there, then place the plotting compass once again on the dot, needle will point somewhere, probably over here, then you draw a dot over there, place the compass at that point or bring a new one. So sometimes they ask you, what is the benefit or the advantage of using small plotting compass? Now this one is like not connected with this specific question. Small plotting compass. What is like the benefit of using small plotting compass as compared to a big plotting compass? So if you have like a big plotting compass, let's say it looks like this. Let's make it more. All right. Then you draw dot over here, another probably over here. Now the problem would be with a large plotting compass, you can draw only a few points. Few points marked. But with a small plotting compass, you can draw more, you can mark more points. And if you mark more, if you're able to mark more points, the magnetic field pattern would be smooth, because you know like about a lot of direction in the way. All right, but in that case, for a large plotting compass, it would not be too smooth.